Hello, future engineers. Welcome to my YouTube channel. There is another video in kinematics of particles. I hope that you will be able to understand the solution and the explanations to these problems. Thereby, your thinking skills in dynamics will be enhanced, particularly mathematics. The vertical motion of mass A is defined by the relation x equals 10 sine 2t plus 15 cosine 2t plus 100, where x and t are expressed in millimeters and seconds, respectively. And of course, this t here would be in seconds, and the angle would be in radians. So set your calculator in the radian mode. Determine letter A, the position, the velocity, and acceleration of A when t is 1 second. And letter B, the maximum velocity and acceleration of A. So first, for the position, all you have to do is substitute t equals 1 second in this equation, and from there we can solve for x, the position. So this is the figure. X or x1 equals 10 sine of 2 times 1, so 2 plus 15 cosine of 2 plus 100. So evaluating using your calculator, x sub 1 is equal to 102.9 mm. The next would be the velocity. Velocity is the derivative of x with respect to time. So v equals v sub x also, d equals dx dt. And the derivative of x position with respect to time is 10 constant times derivative of sine, which is cosine of 2t, times derivative of 2t with respect to t is 2. So 10 times cosine 2t times 2. So that makes it 20 cosine 2t. While the derivative of 15 cosine 2t is 15 times negative sine 2t times 2. So that would be negative 30 times sine 2t. And of course, derivative of 100 is 0. That's constant. So v dx dt is 10 cosine of 2t times 2 plus 15 times negative sine of 2t times 2. Simplifying, v is equal to 20 cosine 2t minus 30 sine of 2t. So substituting t equals 1, v is equal to 20 cosine of 2 minus 30 sine of 2. So the velocity is equal to negative 35.60 mm per second when t is 1 second. Then the acceleration of A. So let's develop an expression for acceleration, which is the derivative of the velocity with respect to time. So this one. So acceleration equals dv dt, and it is equal to 20 times negative sine of 2t times 2 minus 30 times cosine of 2t times 2. Simplifying, acceleration, which is derivative of velocity with respect to time, equals negative 40 sine 2t minus 60 cosine 2t. Then substituting t equals 1, acceleration is equal to dv dt equals negative 40 sine of 2 minus 60 cosine of 2. So using the calculator, acceleration equals negative 11.40 mm per second square when t is 1 second. Then letter B, the maximum velocity and acceleration of A. So to obtain maximum velocity and acceleration of A, we differentiate velocity with respect to time and equate it to 0. So acceleration dv dt is to maximize the velocity, we differentiate v with respect to time and equate to 0. So v equals 20 cosine 2t minus 30 sine 2t. Differentiating dv dt is equal to 20 times negative sine 2t times 2 minus 30 cosine of 2t times 2. Simplifying dv dt is equal to negative 40 sine 2t minus 60 cosine of 2t. Then we equate it to 0 because we want to maximize the velocity. And we have to find the time for v maximum. So we have negative 40 sine 2t equals 60 cosine 2t. So that means sine 2t over cosine 2t, which is tangent of 2t, equals negative 6 equals 60 over negative 40, or that's negative 3/2. And take note that there are two quadrants where the tangent is negative, in the second and in the fourth. In the second quadrant, the angle using your calculator should be inverse tangent of negative 3/2. Whatever is the value, it will give us a negative value. Then since it is in the second quadrant here, then the actual angle in radians should be pi, or 180 degrees, minus whatever is the result here. So that is 2t equals pi plus negative 0.9828. Inverse tangent of negative 3/2 is negative 0.9828. And since the angle is in the second quadrant, then the angle should be 2t should be pi 180 degrees minus 0.9828 by treating the angle positive. So it is now in the second quadrant. So one possible value of t is equal to 1.079 seconds. The other possible value of 2t, tangent 2t, is also negative in the fourth quadrant. So the angle should be 2 pi plus the negative of whatever is this angle here. So take note that in the fourth quadrant, if this is the angle, then this is the negative angle. So it is 360 degrees plus that negative angle, or 2 pi, because the angle should be in radians, 2 pi minus 0.9828. So 2t is also 2 pi minus 0.9828. Then t is equal to 2.6502 seconds. So there are two values. One we evaluate when t is 1.079 seconds, and the other when t is 2.6502 seconds. And then let's compare. So for t equals 1.079, Vmax equals 20 cosine of 2 quantity 2 times 1.079 minus 30 sine of 2 times 1.079. So the maximum velocity is negative 36.06 mm per second. So it's negative, so meaning to say it's going to the left. But let us evaluate also when t is 2.6502, the velocity might be positive at this time. So Vmax is also 20 cosine of quantity 2 times 2.6502 minus 30 sine of quantity 2 times 2.6502. So Vmax is equal to 36.06 mm per second, because this is positive, although they have the same magnitude. But I'll make this the answer because it is positive. Although velocity, because it is a vector, can be positive or negative. But the magnitudes are the same, so let's have that as the final answer. Then for the acceleration, maximum acceleration, I have to derive acceleration, which is dv dt, and equate it to 0. So acceleration is negative 40 sine 2t minus 60 cosine 40. So dA dt is equal to negative 40 times cosine 2t times 2 minus 60 negative sine 2t times 2, simplifying and equate to 0. So dA dt is equal to negative 40 cosine 2t minus 60 times negative sine 2t times 2 equals 0. So it's the same. So 120 sine of 2t equals, this is positive 120 sine 2t equals 80 cosine 2t. So tangent of 2t equals 80 over 120 or 2/3. And again, take note, there are two quadrants where the tangent function is positive, in the first and in the third. In the first, so inverse tangent of 2/3 divided by 2, that's the t, 0.294 seconds. And if it is in the third quadrant, the angle inverse tangent of 2/3, we add pi, so for 180 degrees, that would be in the third quadrant. So, and 2t equals pi plus 0.588 because inverse tangent of 2/3 is 0.588 radians. Then that's 3.7296 seconds. So t would be equal to 1.865 seconds. So at t equals 0.294 seconds, A max is negative 40 sine of 2 times 1.865 minus 60 cosine of 2 times 1.865. So A max equals 72.11 mm per second square. I will leave to you to evaluate the acceleration when t is 0.294 seconds, and it will give us maximum acceleration equal to this value here, 72.11 mm per second square. So that's it. As I said, I want to leave this to you. Evaluate acceleration when t is 0.294 seconds and verify that this is really the maximum acceleration.